So we're talking about what areas of regular polygons.
What?
So I know it's been a while. I know it's also we're talking about regular polygons, but what makes a regular polygon a regular polygon? Remember? No, what about the sides?
They're closed.
They're closed. Okay. Well, that would be a regular polygon or a general polygon. Would you say?
They're usually very complicated.
They're usually concave.
Nah.
No, not concave. Yeah, they can be concave. They're convex. What else?
All the sides and angles are congruent.
There we go. All the sides and angles are That's what we're looking for. Okay? So we're going to have all congruent sides and all congruent angles. Okay? In this figure, how many sides does this one have? It's a circle. Okay, it's a circle. Inside the circle we have a
Pentagon.
pentagon. It's got 5 sides. So in the figure, a regular pentagon is inscribed. I'm going to cheat sheet today because we've got vocabulary words that I don't know how to spell off the top of my head. Inscribed means on the inside. So notice that the pentagon is inside the circle, so we say it's inscribed. Inside. Okay? It's inscribed in the circle P, meaning the pentagon is inside the circle with its vertices on the circle edge. Notice that right here, here, they're all connected. Right? So then we can say the circle is circumscribed. You say that one really carefully.
Oh, I get it.
Circumscribed, meaning it's on the outside. So inscribed means on the inside, circumscribed means on the outside. Right? So the center of the regular polygon and the radius of the regular polygon are also the center and radius of this. We've talked about an apophthegm before, I think. Has that come up?
No.
No? Okay. Apophthegm. It sounds like you're saying opossum or maybe a lisp. It's kind of funny. Apophthegm. It's kind of fun to say. It's a segment drawn from, drawn perpendicular. Drawn perpendicular to the side of a regular polygon. Okay. Our apophthegm over here would be FP because it is perpendicular. We've got the right angle to one of the sides and it's drawn to the center. Okay. The triangle form is an isosceles triangle. Think after how many times I've written isosceles, I would know this. Okay, because I know this side is going to be the same length as this side. How do I know that they have to be the same?
Because the regular polygons, I can't think about one side, the ones for the pentagon are all the same, so then they'll be the equal distance.
Okay, true. What if I was looking at the circle?
Well, the radius is the same.
And the radius is that's the radius. But you were going in the right direction too. Yep. So I know that they are radii, so I know they have to be the same because all radii have to be. You're in the same circle. Alright. Central angle of a regular polygon. The vertex is at the center of the polygon and its sides pass through consecutive vertices of the polygon. Okay, so in this case, the central angle would be this. Okay, and to find the measure of the central angle of a regular ingon, we're going to just take 360 and divide it by however many sides we have. Which makes sense because I know this was going to be a whole circle, so if I was going to draw radii from the center to each vertex, it's going to cut it into 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, 5 pieces because there are 5 vertices. So I know you just take 360 divided by 5 will get you an 8. Questions so far? Okay, let's see what we can do with some examples. So what is 360 divided by 5 radius? It gives us this, the measure of the central angle.
Oh, okay.
Okay. Okay, step 1 says in the figure, this square is inscribed in the circle K. Identify each of the following. So we're looking through here. What's the center?
K.
It's pretty easy. Okay, how about the radius?
K3.
What else?
K8.
Okay, those are the only ones that are drawn in there. We could read more if we wanted to, but that's what's drawn. Okay, what is the apollo? Now. And name the central angle. Good. And name the central angle. How are we going to find it?
36 divided by 365.
By 4, because we got both sides of the square, which gives us what?
100. We all sound so excited.
I know. We can barely contain ourselves. Okay, in this one, we've got a regular hexagon inscribed in the circle, and again, they're identifying all the following. Okay, tell me what the center is.
R.
R. What's the radius? Okay, what are times the radius is it going to go to the circle? Has to go to the edge.
I forgot.
Or I shouldn't say the edge, it has to go to the corner.
I haven't really asked this question, but when you name them, do you have to start with R?
No, you don't have to. I usually do. Alright, how about an apostle?
RS.
Yes. Central angle.
KR.
And how do we find its measure?
We provided 360 divided by 5.
Okay, how many sides we got? 6, because it's a hexagon. So 360 divided by 6 is 8. 60.
60 degrees.
Okay, versus the corner face. Alright. Moving on. We have a stained glass window over here. It says the area of a regular polygon can be found by dividing the polygon into congruent triangles. Remember how we said, well, we could draw a line from the center to a corner, and it's going to divide it into congruent triangles. And they've already drawn these. There's this one. How many congruent triangles are there?
I don't know, there's too many lines, it's kind of confusing.
8. How do we know there's 8? You don't even have to really...
8 sides.
8 sides. Okay, so it says over here that the stained glass window is shown. The window is a regular octagon with side lengths of 15 inches and a bottom of 18.1 inches. What is the area covered by the window? So what I would do is I would just pull out one of our triangles. I'm going to pull out this bottom one because they've already drawn it for us. And I'm going to draw it over here. Okay, they give us this. And this is 15. Quarter is, what did we tell?
Oh, he said, the corner is 15. And
It's 18 high.
18.
21.
Where's the 61?
Oh, that's 0.1.
Yes, 18. Okay, so it asks us what is the area covered by the window. Well, we already said that we can cut this into 8 congruent triangles. We only have to find the area of 1 and then take 8 to figure out the area of the whole thing, correct? So how do we find the area of this triangle?
Every base times height times half.
Okay, so what is our base?
15.
And what's our height?
18.1.
Okay, so the area for one triangle,
It's 135.75.
135.
And then you times that by 8. So then the area is 1,086. Yeah.
Okay, so that is one way to figure out the area covered by a regular polygon. Instead of having to find just one of the triangles and multiply by how many there are, you can use the nice little formula down here, which tells us the area of a regular polygon can be found by using this. Area equals half times A times base T, where A is going to be our apothem. P is perimeter, and P is perimeter. Okay. Let's see what we can do with this next example. Again, we're finding the area of each regular polygon, and then I'm going to round the nearest 10. Remember, never, 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 ever round in the middle of the problem. We're going to round it to the middle of the area. Alright, so they give us a triangle that's already drawn in there for us. I'm going to draw it off to the side so I can make it bigger so we can draw stuff in. Okay. Label what we know. That's it. That's all we know.
And then D is symbolizing the apostrophe.
BD is the apostrophe. Yes. We don't know the length of it. All we know is quarter to quarter is. What else do we find? Perimeter. Okay, we found the perimeter. How are we going to do that? Which is 18. Okay.
Wait, where'd you get the 6?
Oh. Is it what do we call it when it's on 6 sides?
Hexagon.
Is that it? Alright, well, in order for us to use our nice little formula, we also need to know how long the apostrophe is.
We can use the 30, 60, 90.
Ooh, do we know if it's actually 30, 69?
No, we don't.
Try.
What about the
Pythagorean theorem. How many sides do we need to know?
Two, we only know one.
So we can have one.
We could just make it like
Oh, now this is dumb. It's that formula.
yeah.
Okay. Yeah. We know. But do we know what the apostrophe is?
No.
No.
Is
Well,
it
but that's how you find it.
Because we don't know the area.
Area equals half the top.
Can we use the one where it's equal sides because its radii are all distinct?
Does this help us any? That's true. These are the same, right?
So it's like hypotenuse equals leg times whatever 2 and square root of 5.
Is that true? Because this is not a right triangle itself, is it?
No.
No. Otherwise, you're totally right. But no, that doesn't work. Not a 45, 45.
Have we learned how to do this?
I want you to look on the front side of your notes. What else do we find? What do you think?
I don't know if on the triangles are not really angles.
Okay, expand on it.
Okay, so like you take triangles and like add 6 of them together. So that would be 64.
Awesome. Can you say, remember when we went back here, we said, oh, we can find the measure of a central angle? So we can say, and find this angle by taking 360 divided by what? 6, because there are 6 sides, which gives us what? 60. Okay, now you have to be very, 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 very careful because it is this whole angle that is 60 degrees. However, we can use either sine, cosine, or tangent with only what kind of triangle?
The right side.
Right triangle. Okay, this whole triangle itself is not a right triangle because neither of these two quarters are right angles. However, we have a right angle in the middle, so I could just take half 169.
So 30 degrees.
Oh, I'm saying this whole time is not a 369 here, but
Yeah, what happened?
yeah, sorry, yes. Because what is this angle now?
There. I was like, what?
Sorry. Wasn't quite following your train of thought there. Yes, you were right. All right, so how long is it from here to here?
125.
Good. Why is it not 3?
Because that's the entire length of the bottom.
It's only half of it. Okay, so now which side are we trying to find again?
The bottom.
The bottom. Which one's the bottom?
The one with the lighting on.
Yep, we're looking for this guy. Okay, how can we find it?
30 times 1.5 divided by 1. Something like that.
Okay, is there an angle?
Isn't it like, if it's a 30-69 triangle, hypotenuse would be times 2, and the, was that the long side would be times root 3?
Yep, long equals 4 times root 3. In this case, because it's a 3069. Yep. So our long side is going to be the A. Our short side is the. So down to our problem. Yay!
So more enough.
All right. So now what are we going to do?
You plug it into the formula that's on top.
Yeah, because our formula said area equals half times the column times the perimeter. We have all our pieces now? Because we know their column and we know the perimeter.
So we're supposed to leave it in terms of volume.
It says rounds when there's 10. So be careful when you type in the root 3 that you're only taking the square root of 3 and not the square root of 3 times 18.
There's a pi.
There's no pi. Should we just say should we have a second answer? No. Should we not? No, because we'll say it says to round out here. So, we plug it all in. What do we got? Tables are labeled. Reader's word. All right, any questions or comments on what we just did, or why we did it, or how we did it? All right, let's try another one. All right, let me give us a different set of information. In this case, they're telling us that this is 10. And that's all they're telling us.
We just do the 365 first.
Sure, we can do that. Why are we going to go 360 divided by
So
5?
now we can find the 60 angle, and then that's then I think we have to find the angle.
Okay.
72.
Okay, so what's 60 divided by 5?
72
So what is 72?
degrees. The top of the angle.
Okay, so again, I would take and I would draw this triangle out here so that we have something to look at here and we can make it fill in what we know. We know this side is 10.
Well, we're going to have to do half of it again.
We are going to have to go half of it again.
32 or 36, I mean. That's one.
Would it be cosine?
No, would it be cosine?
Or would it be sine?
So 36, right?
Mm-hmm.
36 degrees.
And the bottom one's 54.
Okay, because which side are we looking for? Yeah, kind of the bottom one. Because we're looking for the column, we're always looking for the one with the right angle, right?
Mm-hmm.
Okay, so what are you saying again? Which we use? Well, come on, somebody. Is it sine or is it cosine?
It's cosine, because you have to, so good. I'm confused.
Well, we don't have the opposite, and we have an adjacent and a hypotenuse.
Right. You're right, because we don't have an opposite, but we've got an adjacent, and we've got the hypotenuse. So we're going to use cosine. So cosine of, well, sure,
36.
36. 10 cosine 36.
No, because then don't you do 10 over 8?
Eight over 10.
So it is.
Which is right. We're going to say cosine is 10. So how long is our problem? It's going to give you a big long decimals, I'm thinking, correct? Okay. However, we should never, never, ever, ever run into the problem. So for right now, we're going to leave the apostrophe like this. And we're going to leave it like that. Just for right now. All right, what else do we need? Yeah, so we need to figure out side length so we can figure out what the perimeter is.
So I know we use soap.
Would we use soap?
Good point.
Oh,
Well, can I just do
Can we do something else now?
It's still have, because we don't have that measure.
Okay,
oh yeah, we thought it was,
you prove it. Yes, technically we could use sympathetic theorem, however, it would be kind of messy because this is a big long decimal and then we will be rounding in the middle of the problem. So, yes, I know that we know what A is and now we know two sides and it's a right triangle and we can use sympathetic theorem. I agree. However, in order to be more accurate and not rounding in the middle of the problem, I would use sine because we're looking for this side, which I'm going to call x. Okay, so in order to find x, now we can use sine. So sine of 36 is x over 10. So again, this is going to get you a big long decimal, which we are now going to round for right this very second. How are we going to use that to figure out what our perimeter is? What is x? If I was going to look back at this big picture over here, where is x?
X is half of the triangle, and the triangle is on one side, so every times x by 200.
It's RS.
Okay, Lindsay Pichetta, please, thank you. All right, so if RS is x, and we're looking for perimeter, times it by 10. Why 10 when I talk sides?
Because it's half of one side.
Exactly. So we're taking this whole thing, times 10, will get you, I guess I should write it like that, because that's x. Times 10 will get you. Okay, is anybody confused by that?
No.
Will you explain to them again? Okay. So now that we have all our pieces, we're going to fill out our formula?
Yes.
Yes. So we've got the apothem, and we've got perimeter. So all we're going to say is half times the apothem, which is this one. Times the perimeter. So now if you wanted to, yeah, you can have all those decimal places in there.
I got 475.5.
It's not what I have written on my paper, but you can be totally
Oh, yeah, I know.
this one. It's just a lot easier to keep all these decimals on your calculator than having to type them back in again, but we'll work it out. What do you come up with?
237.95.
I got 237.8.
Because we're gonna round it to the nearest.
Yeah.
Are we in meters or feet or what are we in? Inches. Yeah, these are not the easiest easiest ones. It's not that it's that hard, you just have to be careful. I would always draw the triangle on the outside and say what you know. Don't try to write it in the little figure because you'll take the triangle. Any questions on that? You want to look at another one? Okay, so last page, we're talking about composite figures. Are just figures that can be separated into regions that are basic figures such as triangles, rectangles, trapezoids. Because we already know how to find the area of all those pieces, because we had all those formulas at the way beginning, let's refresh our memories. How do we find the area of a rectangle?
It's the base times height.
Okay, how about for a triangle?
1/2 times base times height.
How about for a trapezoid?
1/2 times height times base 1 plus base 2.
Okay. Okay, how about for a rhombus?
1/2 times diagonal 1 times diagonal 2.
Good. Which is the same for a
Height.
Oh, and then we just have circle. Square. Was it off this anything? I think that's it.
Got a lot of them.
Well, that's the same as a.
Rectangle.
Okay, so basically when we're looking at these figures, composite figures are kind of weird looking shapes. They're not regular shapes, but we can cut them into pieces, and each of those pieces we'll be able to find the area of. So we're looking at this first one. What pieces are we going to cut this into?
From a half a circle, a triangle, and a rectangle.
Right, they've already got our nice little dotted lines of where we can cut it apart. So if we're looking at, I don't know, which piece do you want to cut here first?
Rectangle.
Circle. Circle. We'll go circle next. All right, we're going to find the area of a rectangle that we're from the base times height. What is the base and height of just this piece?
4, 8, 7.
Which would be 28 feet squared. Right. Well, we're equals 28. Okay, now let's look at the half a circle. What's our formula?
Higher squared.
But since we only want half a circle, we're going to take it times half. Alright, so what is our radius?
Four.
Good, 4. So I would leave it in terms of pi for this minute. So let's do pi. Okay, and then our last piece is this triangle. I've done the area of triangle. We have to square. Oh. Thank you. Thank you. Alright, what about this triangle? What's the base and height?
Base is 4.
It's like the same thing. Well, can we assume that?
No.
No, that shall never assume. Okay. How are we going to figure out how long that is?
You can use the bag. I take them down.
We can use the Pythagorean theorem. How do we know?
Because we've got 4 sides, because we know 2 sides.
Okay, but
Because like the lines
how
are
it
perpendicular
works.
to the lines of the triangle.
How do we know it? It's not in there, it doesn't show me.
Because
Lindsay, get your answers.
Because
Because the rectangle has 4 right sides, and since it's exactly a straight line with the rectangle, it's separated.
that's what I was going to say.
Yep. Alright, so let's go off to the side here. A squared plus b squared is c squared. What are we going to plug in? 4 goes to
5.7 goes for C.
Let's see. Calculator says. Okay, is that a nice perfect square? No. So I would just say for right now, it's a square root of 16.9. So So this is our height over here. Square root of 16.49. Alright, so since we found the area of each piece, if I'm going to find the area of the whole figure, all we have to do is add them all together. So we're going to take the area of the rectangle, which is 8, plus the area of the triangle, which we could simplify as half equals 2. So it'd be 2 times the square root of 16.49, plus the area of the circle, 8 pi. If they wanted us to have an exact answer, that would be our answer. However, most times they're going to want you to round to the nearest 10. So you type in a calculator, put in pi, make sure you're only taking pi times 8, figure out what the square root of the 16.49 times 2 is, and add everything together.
Don't round the circle for the pi one here.
Don't round to the very end, so keep all those decimals on your calculator, and just add it. So that's rounded. This one is exact. Any questions? What's that?
Wouldn't it be 4 pi if it's going down to the
We already took half of it because we said 4 squared was 16 and half is 4. Alright, let's see what we can do with B. It doesn't give us dotted lines on where we can cut it apart. We think.
I kind of made it 2 rectangles and a triangle.
2 rectangles at a time. So I'm assuming you went there and there?
Mm-hmm.
Did you do a rectangle?
Why can't you just make a rectangle?
Why can't we just make a rectangle? Is that what you're saying, Ashley?
It's just having one missing corner.
So you want me to cut it this way?
No,
This way?
make an actual big one rectangle. Why can't you do that? Bring the corner, bring
You want to add in something like that? Okay.
Because we already know that the 5 side is the same as the 12 side, so the missing top side part is from the 8. So in the top part, since it's over to the bottom, it's
So we're right.
It's a 45.
It is a 45. Okay, so could we do it this way? We would find as if there was not this corner and then find the corner and subtract. We could do it that way. We could totally do like you were saying, Krista, where we can cut it here and cut it here or whatever and find
It
the
seems a
piece.
lot more easy.
We could do it that way. Or Ashley was saying something about a trapezoid. If we had cut it there, we also find the area of those pieces and add them together. Yeah. In other words, this one has many, many, many ways of doing it. Which way would you like it?
Yeah. Right square that.
All right. So what are we gonna do?
Then find the third area.
Okay. So we'll say whole thing minus the missing corner. All right. So how do we find the area of the whole thing as if it was not missing a corner?
Well, it's the rectangle, so it's not tight.
Okay. And how are we gonna find the area of what is missing?
We have to reduce the area and use the figure theorem.
Do we have to use the Pythagorean theorem?
No.
Oh, you can use the 45, 45, 90.
Do we have to use that either?
No.
No. Do we know the base and height?
Yeah.
What are they?
There's 7 and 7.
They're 7 and 7. Something more worth you have to, right? All right. So what's 12 times 15? Is it really? All right. I'll take your word for it. Okay. And then 7 times 7 is 49. Half of 49 is? Half of 49 is something. All right. we subtract, what do we end up with? Sorry?
155.
That's whole line is in the
All right, do you want to do the last one, or you guys got the idea?
Got the idea.
Idea?
Not time.
Um,
More time.